All right, so first thing we're going to do is add or subtract radicals. To do that, the first step we got to do is simplify the radical. So to simplify the radical, we've done this before, is to look inside the radical. So we're going to look inside the radical and see if we can simplify it. So since this is a square root, we're going to look at the square root table. So we're going to look to see which of these numbers can go into both 3 and 75. Okay, 3 is a little too small. The only number that goes into 3 is 1. So we can't do anything there. So 3 is already simplified. So the first one is already simplified. 8 times the square root of 3. But the second one, 75, 25 is the biggest number that goes into 75 evenly. 36 doesn't, 49 doesn't, 64 doesn't, 81 is too big. Okay, so what I'm going to do is I'm going to change the way it's written. So instead of 75, I'm going to put 25 times 3, because 25 goes into 75 3 times. Okay, so because of that, now this guy has a square root. The square root of 25 is 5. So I can rewrite that as 6 times 5. The 3 has to stay in. Okay, that's step 1. And then I can multiply those two guys together to get 30. That's step 1. Step 2 is combine like terms. Both of these guys have a square root of 3. They're like terms. So to add them together, what I'm going to do is I'm going to add their coefficients. So I can add their coefficients to make 38. And since they were like terms, they both had a square root of 3. And I'm done. Okay, that's addition. Subtraction works the same way. The only difference is you're subtracting. Okay? So since they both have subtraction signs or minus signs in front of them, there's really a -1 here that we don't write. So I'll just put that -1 there. You don't have to, but it's going to be helpful later on down the road. So I'm going to simplify 72. So the biggest number, again, this is square roots, so I'm only looking at this list. The biggest number from here that goes into 72 is 36. 36, so I can rewrite this as 36 times 2. Okay. The biggest number from the list that goes into 200 is 100. 100 times 2. Okay, so now I have a square root here. So the square root of 36 is 6. So it's going to be -1 times 6. 2 stays in. This is going to be the square root of 100, which is 10. The 2 has to stay in. So now I can multiply. I get -6 square root of 2 minus 10 square root of 2. So just like the last one, these are like terms. Because they're like terms, I can add or subtract the coefficients. So -6 minus 10. -16 times root 2. So rational numbers are numbers that can be written as fractions or ratios. Ratios and fractions are the same thing. Okay? If they're not fractions, another way to tell is repeating decimals. Decimals that repeat, like something like 0.3333, or 0.5555, or something like this, 0.58, 0.5858, 5/8. As long as it repeats the same number or numbers over and over again, it's repeating. Terminating means it stops. So 2.5, that's a terminating decimal because there's nothing after the 5 except for zeros, right? So those are rational numbers. Irrational numbers are numbers that can't be written as fractions or ratios. Why not? Because they're non-terminating decimals. So they keep going forever and ever and ever and don't repeat. Never repeat. Okay? And they never end. All right? So the first one, 2a, this I can divide to make -5. -5 stops there, doesn't have a decimal, right? If it did have a decimal, it'd be like that, right? Well, we don't need to write those zeros. So this guy is going to be rational. Square root of 36. Well, the square root of 36 is 6. Same thing like -5. It ends, it terminates, so that's rational as well. 1/3 is already a fraction. 1/3 is already a fraction. And if I were to write it as a decimal, it would be 3, 3, 3, 3, 3, repeating. Either way, a fraction or a repeating decimal, it's still rational. The square root of 140. Well, 140 is not on my list. So 140 is not on my list of square roots. But one of these numbers is. Okay, so I'm going to simplify it first. Before I make a decision, I need to simplify it. So the biggest number, I believe, is 4. I believe 4 is the biggest number that goes into both. So 140 divided by 4, yes. So 4 is the biggest number from that list that goes in. So since it has a square root, the square root of 4 is 2. 35 has to stay because none of those numbers on the list go into 35. Okay, so the square root of 35. So 2 times the square root of 35. The square root of 35 is that decimal there. That decimal doesn't end and it doesn't repeat. Just because the calculator stopped writing it doesn't mean that it stopped. It keeps going, but the calculator stops after a certain point. So that one doesn't repeat and it doesn't terminate. So this guy right here is going to be irrational. Okay. This guy, well, the square root of 4 is 2. The square root of 25 is 5. That's just 10. That really is just 10. Square root of 4 times the square root of 5 is just 10. And 10 is rational. So this guy here, this guy's a little tricky. It kind of does repeat. It does definitely have a pattern, right? It does have a pattern. It goes 0.82, then 0.822, then 8.8222, and then 82222, right? It has a pattern, but it's not repeating. It's not, for it to repeat, it would have to be 0.8282, oops. 82, 82, 82, so on and so forth. Or 0.828, 828, 828. And it's not doing that, right? It's adding a 2 every time. That's a pattern, but it's not going to be a repeating decimal. So because of this, this is actually irrational. Okay. So number 3, which of these represents an irrational number? Well, let's kind of go into them. Let's look at the first one, number 1. The square root of 16 is 4. The square root of 1 is 1. That just makes 5. 5 is a rational number. This guy here, the square root of 25 is 5. The square root of 4 is 2. That's 7. That's a rational number. This guy here. Square root of 36 is 6 plus. Square root of 7, though, 7 is nowhere on this list here. It's not a perfect square. And the only one that goes into 7 is 1. So we can't really do anything with that. So what do? We just leave it. You just leave it as the square root of 7. This guy, the square root of 49 is 7. The square root of 3, or of 9 is 3. So that really is 10. So we have 5, 7, and 10. Those are all rational. This guy here is not rational because 7, the square root of 7, is an irrational number. So the square root of 7 is that. That doesn't repeat. And like again, it looks like it terminates after the 1 there, but it really doesn't. The calculator just stopped writing it. Okay? So that one is going to be my irrational. That one gives me irrational. Those two. Okay? Example number 4. Okay, so which of the following is an irrational? Well, these two are fractions. So it doesn't matter what two fractions you add up together, you're always going to get a fraction answer. And fractions are always rational. So this guy will always equal a rational number. This guy over here, you can multiply both of them, and you'd get the square root of 25. Well, the square root of 25 is 5. That's a rational number. So we got another rational. Number 2, the square root of 2 is not a rational number. So when you add that with a rational number, you're going to get irrational. And then the last one, I'll show you why it's rational. The last one is 3 times the square root of 49. That's just 7. 7 times 7 is 49. So that really is just 21, and 21 is a rational number. So the only one that doesn't have a rational answer is Roman numeral 2. Okay, because the square root of 2, since the square root of 2 isn't on my list, these are the square roots here. These are all the square roots. Perfect squares. These are all the perfect squares, and 2 is nowhere on this list, so it's not a perfect square. So any number that's not a perfect square, its square root will be something irrational. Okay. Okay, so we have to find the sum. Sum means addition. So I'm going to add 3 root 5 plus 4 root 25. Okay, so the sum. So anytime we're adding or subtracting, the first thing we're going to do is see if we can simplify the radical. So 5, we can't simplify anymore because there's no numbers on our list that go into 5. Besides 1. But 25, the square root of 25 is actually 5. So I'm going to rewrite this. So instead of 25, I'm going to put 5 because the square root of 25 is 5. So then I can multiply and I get 20. So I get 3 times the square root of 5 plus 20. Well, these aren't like terms. If this had a square root of 5 with it, they would be like terms, but they didn't. They don't. So this is the sum. That's as far as we can simplify. And is it rational or irrational? Well, because it still has a root, because of that root left over that I can't simplify, it's going to be irrational. So if anything has a root left over that you can't simplify, it's always irrational. Okay. And then the last problem, product. Product means multiply. So anytime you're multiplying, you're going to multiply coefficient times coefficient. Coefficients are the numbers in front. So coefficient. So 3 times 4, you get 12. And then you're going to multiply radicands times radicands. So 5 times 25 is the square root of 125. Okay, that's the first step. Second step is, let's see if this guy, let's see if any of our square roots can go into 125. And the biggest number that goes into 125 is 25. So I'm going to rewrite it as 25. So we're going to rewrite this as 12 times the square root of 25 times 5. And the square root of 25 is 5. So then it's going to be 12 times 5. The other 5 has to stay in because that one's not on my list. And 12 times 5 is 60, root 5. Okay, that's the product. Again, it has a radical left over. It has a radical left over that we can't simplify. So if it has that, it's going to be irrational.